guys, we've done our introductory presentation about atomic bonding, where you learn terms like ionic bonding and covalent bonding and metallic bonding. Let's talk a little bit more about what's actually going on in these bonds. Let's start off with covalent bonding and hydrogen atoms, two hydrogen atoms. So I'm going to draw the protons as simplified, just as plus signs here, because the nucleus is positive because of the protons in it, so I'm not going to draw all the neutrons at all. Remember, neutrons are neutral, so they don't affect the charge of the atom at all. They affect the atomic mass, but they don't affect the charge. All right, a hydrogen atom has one electron. So here are two hydrogen atoms, each with their one electron in their energy shell, okay? When you have a hydrogen atom and it only has the one electron, the first shell is its valence shell. That's the outermost shell. And atoms want that outermost shell filled so that they're stable. They feel content, they feel fulfilled, whatever you want to call it. But it makes the atoms stable. They're not stable. They're in an awkward energy state if they don't have that valence shell filled. So one electron is not satisfying to these atoms. What happens when they're actually bonding is the positivity of the proton here is attracting the electron of the other atom. And likewise, the positivity of this hydrogen atom is attracting the negativity of the electron of this other atom. So what will happen with this is that they end up pulling together. So I'll just redraw it down here with them closer together now. So they've come much, much closer together. Now what can happen is that they are both sharing these two electrons in their valence shell. So they both feel as if they have two electrons in their valence shell, and so now they're stable. So that's why hydrogen, you can usually find hydrogen as a pair. Gases often exist as molecules, well, some of the gases, I should say. Sorry, some gases often exist as molecules. Oxygen is one and hydrogen is one, where they will almost always be in a pair like this. So this is called a duet, when you have the two valence electrons in the valence shell, and you only have this one shell. So this is a duet. This is a time when the atom is completed by having its duet, its two valence electrons. All right, so now let's talk about covalent bonding in water. So here I've got an oxygen atom. Oxygen's a fairly large atom, and here I have two hydrogen atoms. So the exact same thing is going to happen, but we're going to end up with a slightly different result here. Bear with me, let's walk it through and then we'll explain that. So you have the same thing here. This proton is attracting that electron, and this proton is attracting this electron. Remember, this wants one. The oxygen also wants one though, because it has its inner shell filled. It has its two electrons on the inner shell, but it only has 6 out here. And the second shell, remember, to be filled needs 8 electrons. So it's missing 2 electrons here. So it's feeling lonely, it's feeling that lack. So here it can gain 1, and that'll give it a 7th electron, and here it can gain, whoops, let me put this on the other side here just to make it a drawing a little bit clearer. And here it can pull this one and make its 8th one. So, and this hydrogen atom here only has its 1 electron, and it is seeking that electron as well. So the exact same thing is going to happen that we drew just a minute ago. Let me erase some of this here. And here is my hydrogen. Here are my 2 hydrogen atoms now with their electrons that they've now brought in. So now I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So now this is a complete valence shell for the oxygen atom, and that's called an octet. Oct meaning 8, remember, like if you're a musician for octave. So an octet is having a complete second valence shell when we did our example with hydrogen, remember that was a duet because there was only two electrons involved in the valence shell of hydrogen. All right, so oxygen's happy it has its octet, but does hydrogen have its duet? So here is its one here, and it will pull one of these other ones. So these two, for example, could now become part of that hydrogen atom, and these two become this part of the hydrogen atom. So if have you seen any of this kind of stuff drawn before, I'm basically drawing Mickey Mouse, right? So that structure is what we're ending up with here. And if I just put, two big eyes here and a nose and a mouth, you'd have Mickey Mouse. So that's the way to remember water. So this is actually a water molecule, this being oxygen, this being hydrogen, this being hydrogen. So here's our two hydrogens and our oxygen together, and boom, there's water. So water is a covalent bond. It's called a polar bond because these hydrogen atoms are going to attract to the same side of the oxygen, leaving this side over here without. So this side is going to become a little more negatively charged, this side slightly more positively charged. And again, these are very subtle differences, but it's enough of a difference that the molecules are charged. And what that allows to have happen then is other water molecules sticking together. This is what causes surface tension, cohesion between water molecules, so that you can pour water or that you can mix water together into one big droplet like you might have done in science classes in years past. So that is how water is formed. It is a type of a covalent bond called a polar covalent bond. And again, the polar part is that the hydrogen molecules are attaching to one side of the oxygen atom, but not the other side. And that creates poles, the positive and negative poles of the molecule. We said a little earlier that hydrogen and oxygen atoms often travel around in pairs. The reason they do that in hydrogen is so that they can share an electron and get their duet. Well, oxygen works the same way. So what I'm showing here are two oxygen atoms on the board. Here's my positively charged proton. Here are my two electrons in the inner shell. That shell is filled. So now on the outer shell, the valence shell, I have 6 electrons. Same thing over here. My two inner electrons, that shell is filled, 6 valence electrons. Remember, the second shell wants 8. We're seeking an octet here. We want to have that 8 valence electron situation so that the atom feels happy. So this does exactly the same thing that the hydrogen was doing. This proton is attracting electrons here. This proton is attracting electrons from here. So that's going to pull the two atoms together into where they can bond. Now let me get rid of my arrows here and you can see what's happening. And so I'm erasing those 4, and what's basically going to happen here is that now you have these shared electrons. So here's my 1, 2, 3, 4, 5, 6, 7, 8 electrons for this one. So that's filled. It has its octet and its valence. And over here we have 1, 2, 3, 4, 5, 6, 7, 8. So they're both filled. So that's why oxygen atoms tend to travel in pairs too. In nature, you don't find a single oxygen atom floating around. You will find oxygen as O2. Same thing with hydrogen. You don't find hydrogen floating around as single atoms. You find it floating around as H2. And this is what we're looking at. The 2 here is that there's 2 hydrogen atoms bonded together into a molecule, not a compound, because they're the same atoms here. So it's a molecule of hydrogen still. It's a duet. And oxygen the same way. So they're traveling in pairs so that they get their octets filled. These are filling duets, these are filling octets. All right, we've been through the introductory lesson where you learned about the terms ionic bonding, covalent bonding. We've been through the demonstration here of covalent bonding, which happens between nonmetals, 2 nonmetals. So now let's talk about ionic bonding. So this is an ionic bond. What I have here is an example of sodium, which has 11. I'm going to change my proton here from just a plus sign to 11 so that you can see that. And this is chloride. So let me write down here sodium and chlorine. All right, so sodium is a metal, chlorine is a gas. So here, when you have an ionic bond, it happens between a metal and a non-metal. So you can see that sodium has 11 protons, which means it also has 11 electrons. So I've got 2 in my inner shell. I have my octet here if this were the valence shell, but it's not because there's 1 more out here. So this is my valence shell out here, and I only have 1 electron in that valence shell, which is going to be problematic. So I've got 11 electrons in my sodium. In chlorine over here, I've got 17 protons, which means I also have 17 electrons. I've got my 2 in my inner shell. I've got my 8 in my second shell, which means that's full. And then I have another 7 out here in this shell. So I'm seeking electrons still. Now something different happens in ionic bonding from covalent bonding. If this was a covalent bond, this proton is attracting, because it's positive, is attracting this negatively charged electron. This proton is attracting this electron, and the 2 just come together. That's not what's happening in ionic bonding. So you can see that the chlorine molecule is more massive. It has a larger proton than the sodium chloride. It's going to exert more force, and it's basically going to take not this one. It's basically going to take this electron from sodium and put it into chlorine. That's going to make sodium happy because now it does not have this electron anymore. It loses its unstable outer shell, and now this becomes its outer shell. And we've added yet another electron in here, making it much happier. And now we have sodium chloride, which is salt. So there is a bond here because now this is an ion. It is short 1 electron that it should have, making it positive because you have 11 protons in the nucleus, but only 10 electrons. So you have more of a positive charge than a negative charge. So this is now a positive ion. Sodium is positive, and the chlorine now has 18 electrons compared to its 17 protons. So it has more negative energy than positive energy. It is now negatively charged. And just like with magnets, opposites are going to attract. This is an electromagnetic attraction that is going to pull these 2 atoms together, a positive binding with a negative. So the atoms are not sharing electrons in this case, like in covalent bonding. This one's giving up an electron, this one's taking the electron, but now they are oppositely charged, and that bonds them together.